So our next session is Building Smarter Factories, the AI Ecosystem Advantage, which brings together leaders from across the AI and manufacturing landscape to discuss how connected ecosystems are accelerating training, optimizing process data, and enabling real-time decision-making on the factory floor. So joining us, we have Eddie Atkins, manufacturing and production expert at Tulip, Siva Lakshmanan, CEO of DeepHow, and Hiren Kumbuchkar, head of product management at Hexagon, and Alvin Clark, AI engineer at Nvidia. Please join me in welcoming them and enjoy the...
Hey, good morning, or good afternoon, everybody. I think we've got the post-lunch spot, so I hope everyone's had their coffee. This is an exciting session. I'm really proud to have these three individuals here to talk about, I think, the exciting AI part. We'll do a quick round of introductions so that you know who we've got on stage, a bit of your backgrounds, a bit of what your companies are doing, giving to on an AI. Maybe most of you have heard, pretty big names, so maybe most of you have heard of your companies. Maybe Siva, you can start.
Thank you, Eddie. Hey, I'm Siva, CEO at DeepHow. DeepHow is a AI-powered operational knowledge management company. Essentially, we simplify capturing operational knowledge in whatever form it exists, be it expert demonstrations or PDF or job instructions, and we leverage AI to convert that into step-by-step instructions that can be served in the flow. In this case, the partnership is about us integrating these instructions that are consumable within Tulip, so that as an operator is working on assembling something or configuring something, he or she has got the step-by-step instructions. So that is what we do.
Yeah, super exciting. And they're in our tech space if anyone wants to see it. So, and then Hiren?
Yeah, so hello everyone. My name is Hiren Kumbuchkar. I'm the head of the product management at Hexagon for our manufacturing software portfolio. Hexagon is a leader in the measurement technology and autonomous solutions. You might know them from the inspection machines, but they have a wide variety of portfolio options with sensors, with devices ranging from scanners, laser trackers, to the shop floor inspection machines, and software technology that goes with it. Primarily, our focus is how do we leverage the data that gets collected on the shop floor, and we collect tremendous amount of data, whether through our software or through the devices that we put on the floor, and leveraging AI to see how best we can utilize data to deliver insights and to take actions based on that.
Yeah, brilliant. I think at a recent event I was with Hexagon, the CEO shared it very well. He put a tape measure up on screen and said, this is what Hexagon do, but at every scale, from the very small to the very big. So lots of exciting products. Like, no, thanks for being here. Alvin with Nvidia.
Yeah, hi, my name's Alvin Clark. I'm Global Developer Relations Manager for Manufacturing and Industrial at Nvidia. We don't make end solutions. Our go-to-market is 100% through our partners like DeepHow, Hexagon, and Tulip. So my role is to help foster the ecosystem and work with our partners to make the adoption of our technology successful and applicable to manufacturing and other fields.
So yeah, thank you all three of you for coming. It's excited to have you here and have this conversation today. We're going to start, I think, something that's on a lot of our minds and a lot of the operators and the manufacturers on the shop floor is, what's the skill? Is AI going to take my jobs? What is it going to bring for me? And I think also a challenge that I hear from a lot of manufacturers is, we have a skills gap, we have a knowledge gap. How are we going to fill that? So I think where I would like to start with DeepHow, very obvious problem that you're solving, as you mentioned, Siva. How are you managing taking AI, and how do you see it implementing the knowledge transfer, knowledge capability building?
Absolutely. I think one of the earliest success stories of Gen AI, I'm going to intentionally using the word Gen AI because there is predictive AI that deals with tabular data that we collect from machines, and Gen AI, which is good with multimodal data, be it audio, video, and text. And one of the early successful stories of Gen AI is actually in the training and enablement space, where, and as you all have noticed with our day-to-day experience, LLM models are really good at synthesizing a lot of information and giving you a second answer that you can relate to. And now take that and then apply that to operational knowledge. Operational knowledge, like I said in the introduction, it exists in different forms. It could be, how do I configure this? Or how do I do this setup operation? How do I do this changeover operation? Or how do I do this digital workflow, posting inventory in my ERP? This knowledge is tacit in nature. By definition, this is not something that you can easily write up or even easily explain more often than not. It is like, hey, you will hear a vibration noise. No, I'm not even hearing it. No, you'll feel it. It's an intuition that I have developed working there for 30 years. And that is how a lot of manufacturing operations happen out of experience. And this was not as evident a problem when people work for 30, 35 years in the same job and then work through it. But once we have shorter tenure in the company, attrition and churns of other rest of the knowledge work creeping into skilled work as well, the focus on capturing this operational knowledge and making it available to people became absolutely important. And I think this is where there's a true non-ambiguous application of generative AI is. If you look at DeepHow and if you look at the application of DeepHow across our 100+ customers, it's as simple as someone just doing something and I'm capturing it and creating a step-by-step instruction that is translated to 80 different languages. I have a quiz. I can train you. I can provide in-the-flow support. I can talk to the video. I can ask questions to the video, so on and so forth. So, and the beauty of this is, it is absolutely aligned to the mutual goal of both the operators and the management, is to be more proficient, is to be better at what I am doing. So there's no real trust or fear of, am I going to lose the job? Hey, you are my trainer. Like, you can't do my thing. There's no question of you doing my thing. So there is a absolute synergy when it comes to this application. And that is what I like about, I like the title as well, knowledge to know-how, right? Knowledge is when it is sitting between your ears, and know-how is when you're transferring it and telling someone how to do it. And that's not an easy task at all. Like, including, if you have kids and if you have taught them how to ride a bicycle, that's a form of a know-how, right? You cannot write it up. You cannot even show it in a video. Oftentimes, they need to see it multiple times, try it. And that's exactly where AI becomes absolutely important.
Exciting. Sounds like as an operator or someone joining the workforce, like that operational knowledge is often hidden, and having using some exciting way to actually extract it and use it and gain I can imagine that's actually quite attractive for people as well. It's not just having the benefit of helping them. So, yeah, very interesting. Maybe here you have lots of complex products and often requiring engineers to make them work and get them in place. Maybe you can share a few words how Hexagon is thinking about that potential skills challenge.
Yeah, so majority of our products, especially in the software world, get used on the shop floor, either for some kind of process planning where a part has been sent from the engineering. You have to think about how to manufacture that part, or further down in the quality area where you have to think about what's the best way to inspect that part so you can be confident that the part is within its specifications and can meet the quality standards. Now, both these disciplines are heavily domain specific. It takes ages and years of experience to learn and understand how to program a part so that it can run without any errors or issues for a given machine configuration. Same thing with the inspection plan. And one of the challenges we are seeing is that loss of domain knowledge as the skilled workforce is retiring or moving on. We have them replaced by young engineers, so we see kind of two issues. Young engineers first getting up to speed on some of these things and these processes, and how do we help them? And then second is, how do they leverage all the knowledge that has been captured or that has been available in the past within the companies and use that knowledge to learn something out of them. So specifically when it comes to Hexagon technologies, we use AI in two ways. One is several of our desktop products now that help in the CAM and the programming area are using the Copilot. And that's the best way, in my opinion, to help ease the learning curve for some of these young engineers, because they can ask these questions and they're getting contextual replies to what is the best way to handle something. But more important, especially in the process planning, where it is very, very critical to understand what machine you are building the process plan for, what part you're actually manufacturing. Something, as Siva said, not everything is documented, not everything is captured. It comes from experience, and this is where AI is helping through the machine learning techniques, because it's learning from all the models, all the previous part and operations that have been performed, and making those recommendations to a CAM programmer to say, for your configuration, for your factory, here is the best way to generate the program. Gets that programmer almost 85 to 90% of the way there, and then the last 10% tweaks is where the programmer can start to apply their expertise.
Yeah, I think like a real interesting trend between both, or theme I'm seeing across both of these, is the operational knowledge is important, the domain knowledge is important, and that is not knowledge that exists on the internet today. You can't go onto ChatGPT and get that knowledge already. Like it has to be knowledge that's local, and with like DeepHow, you're easily capturing the skills that is your knowledge, and then having a way to access it and use it quickly. And there's also the same with the programming of the CMMs. It's not a generic set of CMM programs and way of programming that Hexagon is developing. It's trained on the CMM programs that your shop is developing in its own specific way. So I think there's a real theme that I'm seeing across both those kind of, how do we close that skill gaps? That's like super interesting. But okay, we've got skills. We've got to get this technology implemented and in use to actually have any benefit and any value. So Alvin, you're working with a lot of partners that are deploying AI solutions, and specifically AI solutions as sort of from a knowledge supports perspective, closing skills gaps. What are the, how do you actually translate that into the operational context? How do you get something to stick and be used by the operational teams?
Yeah, I mean, insights have to be real time, right? Waiting 2 days for a report, waiting for something else, that's not tangible business value. So it's not about generating intelligence into a log file or generating whatever it might be, is how can you drive AI directly into a decision, right? Because ultimately, whether you're an operator, whether you're a factory manager, you're trying to derive intelligence, and how do I fix this error? How do I commission this machine? How is my my factory doing today versus yesterday, right? And so really, and that's kind of where the power of the ecosystem and where Tulip and platforms like it come into play, is that AI is nothing without data. You can have a really highly accurate model. You can you can have stuff, really fast GPUs. You can have a data center. But if you're not giving it the right data, it's sort of garbage in, garbage out, right? And then how do you contextualize, right? So how do you get it so that it's not a generic insight that you're going to get, but it's something specific to your own operations, to the way the capabilities are. So as these agents start working together, start getting deployed, DeepHow is a great example of that, right? Tied in with the videos for the training, the capability, tied in with other aspects from the platform where they can request information, where it can be able to do that. We're actually working on something with DeepHow where we're going to be able to actually look at in real time standard operating procedures as someone doing assemblies, and not just checking, hey, is there a screw there, or is there a part there? We're actually being able to look at the micro actions, all the assembly actions, the spatial temporal information into that SOP, and be able to provide in real time to that operator, hey, you missed a step, or you should have done this step this way, or this is the best way to do that. And so you're actually you're providing that assistance or that insight in real time. And so that's something we're really interested about. And then you get more of the sensor fusion, the capability, right? What can you do with one camera? I can do SOP monitoring now. I can do inspection. I can do factory playback, as was shown this morning. I can do any number of things. And so now you're able to, the scalability of all these different agents that are able to use the infrastructure, to able to use the data platform, are really where it's going to be exciting. And I think when, in a couple of years' times, when we're not talking about fully automated, it's still going to be human in the loop, but it's very much in line with what was talked about in the keynote this morning. We're talking about like super operators was kind of what was mentioned. I call it what the phrase I use is I say giving our operators AI superpowers.
Superpowers, yeah.
So that they're able to do more and be more proficient. And ultimately, if you're more empowered, if you're more knowledgeable, if you know more about the process and everything else, then that just makes you feel good in your job. And we've actually seen feedback coming back saying, hey, we thought everybody was going to be concerned when we started doing co-pilots, but they actually felt more secure in their jobs. They felt more empowered because the knowledge is there, right? The know-how, that knowledge is being transferred and that know-how is being delivered.
So it becomes something that is valuable to me. I use it. It becomes a superpower that I have. So I don't resist it. I use it. Yeah.
And those insights are the more insights you have, you can go from not being able to monitor your factory, but you're able to understand your factory in real time, right? You don't have smart manufacturing, you have self-improving manufacturing, right? That's ongoing, what we call the AI flywheel, but I think what was this morning was probably contextualized a little bit better in terms of continuous transformation.
Yep. So let's move on to data. I think that's it's definitely the next topic. Like we're generating a lot of data across sensors, across systems, and relying on very large analysis on complex data. So how do we think about processing that data and handling it? And maybe Alvin, for you again.
I mean, there's probably not a lot of places in the world where you have this many different types of data like you have in the manufacturing floor. You could have time series data, you could have data from PLCs, control systems, video cameras, different even video systems. You can have video systems that are for quality inspection, you can have facilities, video systems. So the ability to fuse those models and create intelligence is really when we talk about the concept of an industrial AI agent. That's really what we're talking about, is multimodality, multi-model. You're not just taking a CNN and doing a bounding box. That's not intelligence, that's a data point, right? But you're able to couple that data point with perhaps, hey, I have a bounding box around an over-extrusion, right? I can now have the agent go and talk to the PLC for the extrusion head and be able to correlate that against the settings for that build and that SKU and tell that operator, hey, the setting's off for what we're building here. Or it might say, hey, the setting is correct. Likely there's a physical error with the extrusion head. And so now you are arriving at that decision making a lot quicker. You're helping that operator go through their analysis. And so ultimately, it's not about detecting the errors, it's about detecting or understanding the genesis of what's causing those errors. And it's to be able to provide insights to help minimize downtime, everything else. Same thing goes with co-pilots, right? So you can have documentation, you can have previous logs, kind of that tribal knowledge. Yep. You can have a chatbot that says, hey, I'm getting error 63 from this machine. What does this mean? And then it's able to go look at the documentation, look at any kind of previous log files where maybe that error has been. And if it's in the middle of the night, then, hey, that SME or that plant manager doesn't have to get a call in the middle of the night. Yeah. That operator is being empowered to make that suggestion, and he knows how to go solves it. And that's ultimately going to minimize downtime and eventually productivity. And one of the things that I always hear is if you increase quality, you increase your margin, right? So if you can catch all those errors, those insights that ultimately lead to better quality, then that's a win-win.
No, makes a lot like that.
But you need the data.
Creating that closed loop system with the data flow makes
But you need the data. So things like the ability to create agents using the Tulip platform, being able to mix all those data and everything else. And we're really happy about that because we don't want to go build it. But we know it's needed. So partnering with Tulip, building that merging the two ecosystems is really what we're really excited about.
Oh, very good. Let's, in terms of maybe move into the quality domain here and on the data side, like your systems, your hardware is generating a lot of different types of data. How do you see customers managing that, and how are you adding value on top of that with AI?
Yeah, absolutely. I mean, data is an asset, and especially where we end up, especially in the quality side, we have tremendous amount of data that can be beneficial to the upstream disciplines, whether it's design, engineering, or in the production phase. A lot of times today we do see that the data is siloed, right? The departments don't necessarily talk to each other. The collaboration is ad hoc, doesn't necessarily happen. So it's one thing to have the data, and it's another thing to be able to use that data, right? To be able to get insights and then make the use of that insights to inform others that can do their job better. So I think, Eddie, you use a pretty good term of closed loop, because that's really what we hear from our customers is we got all this valuable data. What do we do with it? How do we make use of it? And that's where these AI-based insights are helping us, right? So one such area we see quite a bit of interest from our customers is the predictive quality. How can we identify issues even before they happen on the shop floor, and how can we improve the quality? One of the ways is to continuously, again, learn from the series of parts that have been analyzed and the quality data has been collected. Can we use that? Can we analyze that and predict potentially what went wrong with that part, whether it was an error in the machine calibration, it was something with the tool, it could be something with the design, the way designer had designed the product and had to be changed in the next revision. So there's a lot of different things that could lead to the poor quality and scrap. But in this case, with the predictive quality, with analyzing this data, if we have a way to provide those insights upfront, and to even take a step further, if we can, within runtime, recalibrate the machine, adjust the machining parameters so that that error doesn't happen. Those are the areas that many of our customers are very interested in looking and exploring.
Yeah, very good. So let's move on. We're here all as an ecosystem, and I think big question is, why do we see it important working together, and is it necessary?
I mean, the complexity of no one's going to be able to do this by themselves. The applicability of AI in manufacturing, industrial, from all the way to the design through the deployment, the different domain expertise, the different sub verticals within manufacturing. There's not going to be one solution where you're going to be able to do it all, right? The ecosystem is the high tide that rises all ships, and it's really a few things, right? The ability to have trusted partners, trusted data sources for the different workloads, the use cases, means that you go from a pilot to a blueprint to a playbook, and that's scalability, right? That's a continuous transformation, right? Because it's not, AI success is not, I got one model and I got the accuracy right on one model, I got the deployment or the one use case right. Success is interoperability and integration, right? I can repeat this over and over again, and I can scale it out across all my multiple sites. And you're gonna need an ecosystem, you're gonna need a set of partners to do that, because everybody's working on different pieces to the puzzle, right? It was interesting, over the course of a week, I went from talking to a partner that was looking at taking a CAD assembly and automatically generating SOP directions to somebody that's able to take that and then render it in photorealistically to train robots or to train humans on it, to somebody that, like DeepHow, that can take those videos and actually train a monitor, to somebody else that can then add defect detection on top of it. That's a whole ecosystem that's eventually potentially has the ability to go from CAD to NPI on a single click of a button of all these interconnected apps and the capabilities. And so that's the really thing to really leverage to, I think, be successful with AI, is to look at that build buy decision, look at those trusted partners, look at those platforms like Tulip that can integrate those partners, connect that all up, because it's siloed apps. It's another way that this is also not going to work. It's when all these agents can work together, when you got software defined commissioning, because I'm Nvidia, GPUs are expensive. So if you buy a single GPU and it's only doing one thing, that's not really good. If I buy a GPU platform, or I invest in a GPU platform, whether it's on the edge all the way to the cloud, most likely hybrid, then you want to be able to get as much out of each of that hardware platform as possible. That means it's multi-agent, is multiple use cases running on that.
And then Siva, maybe you're one of these solutions that's sort of part of an ecosystem. How do you think about, as a product, what parts you need to play and how you interact with other parts of the ecosystem?
Yeah, there are two distinct perspectives on this, right? One is the ecosystem is the way to go, like Alvin said. And there is also some reminiscent bad taste about integration from early 2000s, when you have this gigantic monolithic systems, hey, we don't integrate unless it has this particular prefix, etc. But one of the things that is key is the integration technologies have come a long way since then, right? There is one of the primary decisions in front of IT previously used to be, hey, I have this X system, and if I buy a Y system, I need to spend gazillion dollars integrating them, right? That's the primary software buying decisions, and it's still today, but that has been the one that dominated the news, right? But that barrier has significantly gone down with the advancement in the integration technologies. There are much, much more sophisticated integration play available. As a matter of fact, the DeepHow Tulip integration, the whole productization of integration took us 2 weeks, right? This is not even one-off integration. You have APIs that you can connect, get the results back and forth, drive it, etc. That is how simple the integration process now is. So the barrier has come down substantially, which makes the much needed ecosystem play much more conducive.
Yep.
So that's one perspective to it. The second perspective to it is, and we have all seen this even in cloud technology when it matured, right? There are one DevOps player, one taking care of security, so on and so forth. Then the hyperscalers came, consolidated, etc. But that transition takes decades, right? We are in the early innings of the AI-enabled factory. We are very, very early innings of the AI-enabled factory. For us to move the dial ecosystem is the only way. As this progresses down the line, yes, there will be obvious consolidation. Technologies will mature. Bigger companies that are doing end-to-end will emerge. But I don't see that happening for next 5 to 10 years. Mm-hmm. So ecosystem is the way to go. And the risk of ecosystem is much, much lower currently to what some of the bad taste left 10 years back is.
From an integration.
Exactly.
Yeah.
And just a funny fact to the integration side, with generative AI, a lot of these agents are just going to be talking English to each other. It's just natural language conversations happening between agents and apps eventually. Yeah, so it's not protocols or anything else. So
yeah. And we have very good. We have I think there's an example of that if anyone hasn't found it in one of the tech booths in the ecosystem with Cognite, the Cognite one. So let's a couple of easy questions to end, of course. Let's see. First one. Let's think 2030, 5 years in the future. What is the factory going to look like? Maybe Hiren, you can start us off.
One area I see where it's going to make an impact again is customers putting their data to use more and more. What the outcome of that I see is the self-optimizing operations, and that's kind of way towards the autonomy that many of the industries are moving forward with. That's the area where data can, prove to be an asset and help you provide the insights that are not only to, help end users with the information, but actually take actions based on that data, based on those insights. Now, obviously, there is a trust factor with that, which I think over time with the confidence in the system and with the technology that will continue to grow. But with that, operations that are otherwise generally very manual today and had to be tracked and traced throughout the factory, I see that there is an element of optimization that will be introduced just purely based on the data and the AI analytics that goes on top of it.
And on the Alvin, how do you see the factory panning out?
It all goes back to the pain points that everybody's facing at the moment, and the one that keeps coming up in the conversations I have, I think, is probably one that a lot of people hear is operations, labor, right? It's not just that we're going to look at a brain drain. It's not that it's just going to be, depending on who you talk to, somewhere between 10 to 30 million jobs in manufacturing that will go unfulfilled by 2030. But it's also the complexity of the things that we're building. And we're at the forefront of that because we're building very complex AI infrastructure through our partners, these new data centers that just consume gigawatts of power, who's very complex in its designs. And so it's not just building the old things, so we're building the complex. So really these applications like DeepHow, these agents that are going to be there, human in the loop, providing assistance. It's not going to be a chat bot providing an answer. It's going to be an agent working alongside that collaborator. So it's really these agents that can perceive, whether it's perception of video, perception of time series data, perception of multi-modality data, that can then reason, right? Plan and then execute alongside the human operators. That's really where I can see 2030, and from across the board, from perhaps adding a co-pilot to a machine that's been installed there for 25, 30 years that can now, those people retired, and now that's providing assistance to the new operators that are coming up to speed on that, all the way up to the brand new greenfield facilities that have digital twins and doing all the simulations and everything else ahead of it. So I do see those agents being deployed across the spectrum.
Super exciting times. We're all going to be working in very exciting factories. Siva, how does that fit with what do you see, what you're thinking about?
I got to be the wet blanket, right, to the question.
Let's go for it.
I think the 5 to 10 years, the factories are going to look very similar to how it looks today. Right, and that is how it looked 5 to 10 years back as well. And there are digital technologies and automation that comes, and I think we tend to overestimate the time it takes to adopt things. Right, the reality is it still takes 4 or 5 years to roll out a technology, simple technologies, leave alone complex technologies. So the horizon for 5-10 years, instead of predicting, I'm just hoping that manufacturing would be a space where people would want to go and work in. And then the traditional challenges of manufacturing frontline goes away, and people are more empowered to work there. And this technology is going to play a major role. And if you talk 20, 30 years, anything can happen. But the shorter horizon, the automation is still going to be linear, and it's going to be very, very human-centric manufacturing process in most industries, is what I predict.
And actually, to add to that, both Siva and I were at a A3 event last week, and there was a keynote, and I really liked the message that the keynote speaker left off with was, it's okay to think big, start small, but be able to scale fast. And it's something that we try to do when we get, hey, what should we doing with AI? And I was like, I can literally sit here for a month and just tell you about all the things that we could probably do with AI. But let's put off to the side and think about what intelligence, if you had it right now, would deliver significant tangible business value, right, in the short term. What is that needle moving use case that that we can look at, and then we start there. We anchor it there as that start small, clock that first win, understand how these applications work, understand the data that's required, and then, but always have that eye to scale faster, scale across different sites, all those challenges that we face.
I'm kind of halfway between. I do think there will be some significant changes in the next 5 years, and I think what excites me is that the technology is getting more accessible. So I think those factories that will be more maybe at the Alvin Heron end of the spectrum might not be the ones that we're looking at, and the nice shiny ones we're looking at today. It might be something that's at a lower maturity level today, but gets the right team that gets excited and finds a problem to solve and uses these technologies to solve a problem. So I think we'll see a bit of both, but there'll be some surprises. There'll be some companies that surprise us. So excited to see that. So on to our final question here before everyone will have a chance to answer some questions on AI and adoption of AI. So do have a think if there's something on your mind. Okay, last thing, piece of advice for leaders in manufacturing that are adopting AI. What should they do today? Siva.
If you believe a technology is going to work, slow rollout is not an option. You got to go fast. And I think there is too many cases of this whole crawl, walk, and run is being adopted. And particularly now, having done technology for manufacturing for 20 years now, it's always like, hey, let the factory come up and then ask. Let them be ready. That sends a message where it's an option, and it leads to non-adoption. It leads to non-standardization of adoption, etc. Slow. It's completely counter-advice, but slow rollout often ends up in a stumbling block and doesn't go anywhere. If you believe in a technology, don't believe in the technology a lot. But if you believe that it's the right technology, go big, go fast. and that's when the value happens.
Yep. And Hiren, how would you add to that?
Yeah, I'm going to go back to the value of data because to me, AI is evolving very quickly, and it is great to see the kind of potential it's opening up. But a lot of its underlying fabric is going to be based on the data that you can provide and that you will provide. And if you want to make it more realistic, more accurate for your own context, it needs to be data that's coming from your factories. So as you think through these things, it's critical that you think about your data strategy. Where is your data? How it's structured? How easily it's accessible? Can it be fed in a meaningful way so that these AI models can use this data for something meaningful? So as we think about these AI initiatives and strategy, in my view, it's equally important to look at the data strategy, and that's where you see some of the companies putting roles like Chief Data Officer, whose role is nothing but thinking about what is the best way to utilize data and do we have good practices in place. And as we put more efforts into this, I think this is going to take more and more importance looking at the data strategy within the factory.
Yeah, thanks, Hiren. And Alvin, anything final to say here?
Yeah, a little bit. I think the kind of leaning in a little bit to what Siva said. One, you got to believe in the technology. You got to believe in the use case. AI for the sake of AI is probably the worst decision anybody can make. You got to anchor it on tangible business value, right? You have to say, if I solve this very hard problem, it is transformative for my organization. Once you're anchored it on that, lean into the ecosystem. The ecosystem is what's going to allow you to go from risk to business velocity, right? Where you're afraid, you don't know how to manage the risk, you don't know how to manage the technology. Bringing in trusted partners to address that use case allows you to go from that, hesitant to adopt the technology to now you're going at business velocity, right? You're able to accelerate your business velocity. Everybody's looking at this. Everybody's looking at how to apply it, everything else. It is not going to be a choice. I think it is these transformations, at every organization, whether it's fast or slow, are happening, and it's the So that's the
awesome
question.
Well, thank you so much. I think that's some super exciting perspectives from slightly different angles within the industry, and hopefully it's been valuable to everyone. We have some time for questions, so if anyone,
Raise your hand.
Haley has a mic at the back. Just raise your hand if anyone has a question.
There, William from Connected Manufacturing. My question is, what do you guys think will be the most prevalent AI agents in smart factories in the next few years?
There isn't going to be one. And one of the reasons that I like working within the manufacturing field is because it's not a one-size-fits-all. Right? Everything's bespoke. Nobody's building the same thing. Nobody builds things the same way. It's how you adapt the technology. So an agent that will be transformative for one organization is not going to be that same agent for another organization. Now you can look at the underlying trends, which is, I got a labor issue I got to address. I got operator assistance, right? I got the some level of automation, insights. I got a cost. So there's going to be, kind of in generic terms, agents that help operators. But in terms of there being a single model, a single agent, a single architecture that's going to address everything for everyone, it's not. So it's going to be those that can take the technology, scale it, adapt it to the enterprise, those tools that allow for that, those platforms, that can take your enterprise data, your organizational data, and create those agents for you. That's really what we're going to see is a prevalent of, just like there was, what was the really cool stat from this morning's keynote? Something like 9,000 different Tulip apps that have been created, something along those lines. It could be that there's going to be that many different AI agents that are running on platforms like Tulip that have been created and adopted for specific organizations for specific use cases. That's my.
Yeah, I haven't. Maybe. And did anyone have anything to add to that? Any other question? I have a question to add to that, I think. So maybe putting it the other way around. If I'm I'm on my manufacturing floor, I'm production engineer, production supervisor. How do I find my first agent to build? How do I try and figure out what's the first agent to build?
Work from the ROI backwards. What is the biggest SQDC problem that you're facing?
Yep.
And identify the use case that's going to address the SQDC, and then see if AI is even a fit for that. Oftentimes, when there starts with an agent and then map it to a use case and then go to an SQDC, is when predominantly these initiatives fail. Whatever is your measurement, start with the measure. What is my biggest pain point? Is it yield? Is it quality? Is it throughput? Is it engagement? Is it first 30 days churn? Then work backwards and then see if an AI agent emerges. If yes, great. If not,
and maybe your agent could be the thing that gives your daily SQDC report. Maybe that needs to be our first agent.
I mean, it could be the intelligence. It could be where you're spending all your resources. Everything else. We had, I talked to a manufacturer. They instrumented a facility. They got cameras everywhere, and every time they're detecting errors at different stations, they have QA techs that are spending 2-3 hours per shift just going through video trying to find out, hey, where was that carrier, or when did this happen? Now you can have an agent where you just ask the video, right? Just kind of like how factory playback works. Now you can ask your DVR system with all your cameras and videos, hey, when did this happen?
You're looking for like the repetitive human knowledge, almost like basic.
I mean, that
knowledge
person knows. I mean,
injection
they have the
costs.
knowledge, right? They know what they're looking for, right? What you want is an agent that's just going to make it really easy for them to go find it, to get that information. So that is what I think Siva was mentioning is start with, if I could just find out which carrier created the dent on my door a lot sooner instead of spending 3 hours looking for it, that's needle moving for me, right? Yeah. So let's start with that. What is that intelligence? What is that question? If I didn't have to spend 3 hours doing this, I could be doing other things.
Yeah,
right?
We have a question here as well.
Yes, Dave Loda from Oshkosh Truck Corp. With AI, as the agents evolve, they're going to get to know operations or us more and more intimately as they learn about us. For example, I sometimes think Grok knows more about me than my wife of 1 year. So it's like, as these AI agents, especially as co-pilots in the manufacturing operations, grow and learn, what are your thoughts and recommendations for the data security guardrails and making sure that data isn't leaked in some way, shape, or form, because those AI agents will learn all about a company's operations. And it's a little disconcerting because it's something that they could, if that information is leaked, all your information is out. And then you look at the government defense side versus the commercial, trade secrets versus actually CUI data. Just curious as to, as these things grow and learn all about us and our operations, what are the guardrails and recommendations from an architecture standpoint you guys would recommend?
you can take that. Or
Yeah, I mean, from my perspective, it's your data. It's whether you decide I'm going to engage with a ChatGPT or Anthropic or a GCP and their AI services, or whether you're going to bring that in-house and you're going to deploy those models within your four walls and that data doesn't leave, right? So even within our organization, we use some of those services. We don't use all those services for everything we do with AI within our company. And so that's really where it kind of comes down to. It's like, what is okay to perhaps use a API endpoint, a third-party API services, rather than bringing in and deploying your own models. And we have the technology and partners that do that, right? It's actually one of the things.
For example, in DeepHow, we don't use third-party models. We use models that are within the four walls. But broadly, right, even if it's an API call, the technology associated with learning from your data or training the model on your data, I think that is well controlled now.
Yeah.
So you can safely assume that your data is not, when you use a B2C solution, go online and chat, but broadly in enterprise solution, that guardrail is fairly well established. Yeah. There is a memory and there is training. Memory is local in nature, that lives and it dies, and you're not using it to train the data. The problem of the opposite, which is the globally trained data leaking in as insights into your organization, that is what is less controllable. That is the nature of LLM. For instance, there is something called language prior. You can think of language prior as the culture we grew up in. when we grow up in a culture, we are naturally having certain biases and certain values. The LLM models are trained on 300 billion parameters. So they're shaped in a particular way. So that comes into the answer. That leaks into the answer. The outside data leaks into the answer. The trained data leaks into the answer. And that is something you need to assume. That's the nature of LLM. That provides a bit of non-deterministic nature. It gives you insights that's otherwise outside of your data, so on and so forth. That is a feature of LLM. But it's the outside, generally trained public data leaking as an answer is where you need to be careful. But your data, if you are working with a reliable provider, you can safely assume the technologies are in place where your data need not be used to train.
And there's technology to address that leakage coming back in, right? NEMO guardrails being one of our SDKs that would allow that essentially allows you essentially are validating the answers coming back as being, correct and applicable to your use case and the context in which you're using those models.
Okay, I think unless there's any more questions, that's all we have time for. So thank you very much and appreciate it.